Hi everybody, so in this video we're going to talk through the solutions to our indices test we just did. Going to try and keep this short and sweet, so without any further ado, let's get into it. So for question 1a, you're asked to, well, for all of question 1, you're asked to simplify the following and give your answer in the form a to the power of n. So that means when we simplify things, it's going to be something to another power is how we'll give our answer. So that can sometimes be a bit of a clue in terms of what they want us to do. So for question 1a, what they want us to do is a to the power of 5 multiplied by a to the power of 3. One of our index law says that if we're asked to multiply two numbers that have the same base number, we can just add the powers. So that would be a to the power of 5 plus 3, or a to the power of 8. There's 8 done. For b, we have 7 to the power of 3, the power of 7. Another one of our index laws says that we have a power to another power, then we can just multiply those powers. So let's keep our same base number, 7, and then multiply our powers. So it's going to be 7 to the power of 3 times 7. If we multiply that out, we get 7 to the power of 21. For c, I'm going to use index law 2, I think. We've got 6 to the power of 11 divided by 6 to the power of 2. So for this question, index law 2 says if we're dividing two numbers that have the same base number, then we can subtract the powers. So top minus bottom, 6 to the power of 11 minus 2. And then if we simplify 11 minus 2, it gives us 9. On to question D, we have 1 over 3 to the power of 3. Again, looking at our index laws, this will be written as 3 to the power of minus 3. That's index law 5 actually. For question 1e, we have the 7th root of 10 squared. Now this is an interesting one that catches a few people out, but we're going to keep our same base number. If 10 is our normal power is going to the top. Then we set up a fraction because we've got a root. So this is the 7th root. So 7 goes on the bottom of that fraction. It's based off of index law 7 if you want to check it against your list. So next up we have our first question that combines a couple of index laws. We have 5 to the power of 7 multiplied by 5 to the power of 3 divided by 5 to the power of 2 multiplied by 5 to the power of 2 again. Now let's set to work, like I said, by simplifying the top and then simplifying the bottom. All of our numbers have a base 5, so it means we can use any of our index laws. Okay, so on the top we're supposed to multiply 5 to the power of 7 times 5 to the power of 3. Multiplying these indices is going to involve using index law 1, where we keep the base number and add our powers. Same thing down the bottom, they've asked us to multiply the indices, so we're going to keep the base number 5 and add the powers, so 2 plus 2. If we simplify these, the top one, 7 plus 3, we've got 5 to the power of 10, and 2 plus 2, we've got 5 to the power of 4. Now, we can still simplify this more because we haven't given it as something to another power. We need to work to simplify it a bit more again. So let's look at our index laws, and index law 2 looks a bit like this. It talks about dividing a power or dividing an index by another index. So what it says is keep the base number as usual and then subtract the powers. So 10 take away 4. So we get 5 to the power of 10 take away 4, which is 6. So there's our final answer for F. On to G. Pretty similar looking question. There's a little additional trick or two here this time. Just trying to make them a little bit harder for you guys. So we've got 11 squared times 11 divided by 11 to the power of 8 times by 11 to the power of 3. So for this question, it's going to be very much the same process. The only thing you need to know to get started is if we just have a normal 11, then we can imagine that that power is 1 here. So 11 to the power of 2 times 11 to the power of 1. Let's add those powers. So we get 11 to the power of 2 plus 1. Again, that's index law 1. That's letting us add those powers. Then down the bottom, same thing. Add the powers, keep the base number, so it's going to be 11 to the power of 8 plus 3. If we simplify these then a little bit, the top is going to be 2 plus 1 gives us 3. So we have 11 to the power of 3. The bottom is going to be 11 to the power of 8 plus 3. So 11 to the power of 11. And again, index law 2 comes into play here because we're dividing now. So we keep the base number, 11, and subtract the powers. Now, a few people got confused here because what they did was they forgot they have to subtract the bottom from the top. So they said 11 minus 3 here, and they got 8. What we actually want to do is 3 minus 11. The index law fairly clearly says we have to take the bottom number away from the top number. So it has to be top minus bottom. So if we get 3 minus 11, it's going to be 11 to the power of minus 8. And it's absolutely fine to have minus powers. Like you can see, we already had one up here with minus 3. Okay, on to another question that's slightly different, but again combines a couple of index laws. It's 7 to the power of 2 to the power of 6 divided by 7 to the power of 3 to the power of 4. So up top, we've got a power to another power, so index law 3 says we can just multiply those powers. So it's going to be 7 to the power of 2 times 6. On the bottom, same thing. We've got a power to another power. So we can multiply those powers, 7 to the power of 3 times 4. Now, if we simplify this out, we're going to get 7 to the power of 2 times 6 will give us 7 to the power of 12, because 2 times 6 is 12. We'll get the same thing on the bottom, because 3 times 4 also gives us 12. Now, this also tricked a few people. So people were saying, well, 7 to the power of 12 divided by 7 to the power of 12. And they put 7 down as their answer. So if we think about this using our index laws, 7 to the power of 12 divided by 7 to the power of 12, index law 2 says that if we're dividing indices, we should subtract the power. So it's going to be top minus bottom, 12 minus 12. A lot of people got 1 for this, 7 to the power of 1, but 12 take away 12 would actually give you 0. Now I asked you to give your power or give your answer in the form 8 to the power of n. You'll remember at the start, 8 to the power of n, so it should be a power to another power. So this would be the most correct answer for this. But some people were pretty clever about it, and they remembered index law 4, which says any number to the power of 0 should be equal to 1. So 1 is an okay answer for this as well. Alright, on to our last question from question 1. Question 1I. So we've got 6 to the power of 5. Multiply by 6 to the power of 5. All to the power of 2. I'm going to put 2 in square brackets here just so I can talk about the brackets a little bit more easily. Now, what we have to think about here is solving brackets from the inside out. So if we can't simplify this anymore, or this anymore, right, because we've been asked to leave them in index form, 6 to the power or something, then what we'll do is we'll work from the inside out. So let's do the inside indices first. We've got 6 to the power of 5 multiplied by 6 to the power of 5. So index law 1 says that we should add those powers. 6 to the power of 5 plus 5. That's what we're going to get in the middle. Then if we go 8 from there a little bit, that still has to be squared. So we can simplify that. 6 to the power of 5 plus 5 will be 6 to the power of 10. And then square that out here. Again, just remember that if you got 2 terms next to each other in brackets and there's nothing in between, you just multiply those terms. That's what they're asking you to do. So this means multiply. So we can use index law 1 when we're multiplying indices. Add the powers. Right, then we've got 6 to the power of 10 to the power of 2. So we can use index law 3, which says we multiply those powers. If it's a power to another power, we multiply them. So 6 to the power of 10 times 2, which gives us 6 to the power of 20. And that's our answer for that. Again, we've got a to the power of n, a number to a power. Let's have a look at question 2 now. So this time we're being asked to solve the following equations. Now, if you were solving an equation, there's going to be some kind of an unknown variable there. I put down x for the unknown variable for all this. So you have to say x is equal to something to get full marks. So I think that's where if you lost a couple of marks, you did some of the workings out, but then you forgot to say at the end x is equal to something else, right? And I had that conversation with a few people in class, and I asked them to make sure they're giving their answers like this. So just there is a reason for that. It's because I want you to get the full marks out that you can. All right, so we have 3 to the power of x. This is for a. 3 to the power of x is equal to 27. So what we want to do is express 27 as 3 to the power of something, right? We want both of these to have the same base number, basically. So we could put into our calculators 3 squared, and it would give us 9. We could put in 3 cubed, and that would actually give us 27. So let's rewrite the right hand side as 3 cubed. So then we get 3 to the power of x is equal to 3 to the power of 3. So if this is going to be true, then the powers must be the same as each other for these two things to be equal or the same. So x then must be equal to 3. For question B, it's going to be a similar thing. 6 to the power of x is equal to 216. We want both of these to be expressed with the same base number. So let's see if we can get this to be a power of 6. So we put into our calculator 6 squared, we get 36. And we put into our calculator 6 cubed, and we get 216. So let's rewrite the right hand side out as 6 cubed, and we'll keep the left hand side the same. When we are doing algebra out, guys, I've said this before, but just make sure you're doing it one underneath the other. So you can see 6 cubed stays the same, 216 changes to, 6 to the power of x stays the same, 216 changes to 6 cubed. It just lets us really easily see how the numbers are changing as we go along. So again, for these to be identical, now that we've got the base numbers, the powers must be the same. If the 6's match, then these must match. So x must be the same as 3. We can say x is equal to 3. For C, similar question again. Got 5 to the power of x. It's a little bit harder this time. It's equal to 25 to the power of 2. Now, we want the base number to be the same on both sides. So we can try and get 25 as a power of 5. So we put into our calculator 5 squared, and it works out. So we're replacing our 25 with 5 squared, and we just remember to keep that extra square there on top. All we've done is change the way we wrote 25. So it's now a power of 5 squared. Our base numbers match up. Now before we go any further, let's just simplify these powers here. So 5 to the power of x stays the same. Then index law 3 says if we have a power to another power, we can multiply those. So 5 to the power of 2 times 2, or let's rewrite that more simply as 5 to the power of 4. Now again, if these two things are to be identical, the base numbers are the same, so the powers must be the same if they have equal value. So we can say x is 4. Again, I would have given you 10 marks if you got down this far, if you had 5 to the power of 4 or something, but you just have to explicitly say what it is. If you're solving an equation, or you've been asked to solve an equation, you let me know really explicitly x is equal to 4 in this case. So question D now gets a little bit trickier again. These are onto more of the harder questions that we would have come across when we were studying indices. So we have 4 to the power of 2x this time. I'm going to draw a line under here. 4 to the power of 2x is equal to 8 to the power of 3. Now we can try rewriting 8 as a power of 4, so we can say 4 squared is 16. We've already gone past it, so we're going to have to take another approach. Let's try write both of these as the power of a smaller base number. So I know that 2 squared will give me 4 and 2 cubed will give me 8. So I'm going to go from there. So I've replaced my 4 with the 2 squared. That 2 squared, or 4, was still to the power of 2x. On the right hand side, 8 becomes 2 cubed. Again, all I've done is I've changed the 8, replaced it for a 2 to the power of 3. It still has the same value, it's still 8, but I've just rewritten it so both sides have the same base number. I made sure that my 2 squared, because it already has an index, I still need to remember about the old index, because that's where people could get tripped up here. And the same thing for the 8. I've replaced the 8 with 2 cubed, and there's an index here, but I still have to make sure I bring the old index down as well. So my 2x comes down, and my 3 comes down as well. Now again, I'm going to use index law 3 to simplify this a little bit. So if we've got a power to another power, 2 times 2x will give me 4x. And on the right hand side, 3 times 3 will give me 9. At this point now, we know that the base numbers are the same, so the powers must be the same. So 4x must be equal to 9. Then to get x by itself, we want to get rid of that 4, so divide both sides by 4. This cancels out on the left hand side, we're left with x. The right hand side we can just leave that as a fraction, 9 divided by 4, because it doesn't go evenly. Question E now is very similar. We've got a 4 and we've got an 8. So if we've already figured out how to get them as the same base number, this one should be a little bit easier. So again, what we're going to do, try and get the base number the same. So our 4 needs to change to 2 squared, so we can have the base number the same as our 8, which is going to change to 2 cubed. Now what I've done here is I've replaced 4 with 2 squared and 8 with 2 cubed. But I still have to remember the old powers as well, our 5x and our 5. So 5x is going to come down here, and 5 is going to come down here. Our old power and our old power. Again, these values are still the same. 4 is the same as 2 squared and 8 is the same as 2 cubed. I'm just writing them in a different way. Index law 3 I'm going to use again now, because I've got a power to another power and a power to another power. So that means I multiply the powers to make that look nicer. So 2, and then 2 times 5x will give me 10x. On the right hand side, 3 times 5 will give me 15. So I've simplified my powers. My base numbers are the same. So then I can say the powers must be the same also if they have to be equal to each other. So 10x here will be equal to 15. As before, we don't really want 10x, we want just x by itself. So let's get rid of that 10 by dividing by 10. Right? 10x means 10 multiplied by x. So the way that we cancel that out is divide. Multiplying is the opposite of dividing. So we're left with x on the left hand side and a 15 over 10 on the right hand side. If you wanted to simplify that down, I would have been delighted to see it, because that simplifies down to 3 over 2. But this would have given you full marks right here either. In an exam question, they might ask you to simplify at the end, and in that case you need to simplify to get full marks, but this will get you 8 or 9 out of 10. Okay, and we're finally on to the last part of question 2, 2f. And here we've got 2 to the power of x is equal to 2 to the power of 7 divided by 4. Similar setup to the last time, and we do have a fraction here this time, but what we really want to do is rewrite this so everything has the same base number. 4 is the biggest number here, so we should be able to rewrite that as 2 to the power of 2, right? Because 2 to the power of 2 equals 4. It's going to work out. So keep everything else the same. 2x is the same. 2 to the power of 7 is the same. And then just we will replace our 4 with 2 squared. Just going to highlight that so you guys can see what I did. 4 is replaced with 2 squared. Everything else stayed the same. And it is important for writing this whole thing out so we can see as we go through what's changing and what's staying the same. And it'll help us keep track of where we are in our sum. Importantly, it also helps me keep track of where you are in your sum when I'm reading them. So 2x stays the same on the left hand side. On the right hand side, we have 2 to the power of 7 divided by 2 to the power of 2. Index law 2 says if we want to simplify this, we subtract those powers. 7 take away 2, top take away bottom. So let's keep the left side still the same. On the right hand side, we've got 7 take away 2. Let's simplify that to 5. Now, if our base number is the same on each side, then we can let the powers equal to each other. So x here must be equal to 5. That's our last equation solved. Let's go on to question 3 now. So in question 3, I ask you to write a couple of numbers in scientific notation. The first one is 360. The second one is 0.00104. So for 360, there's a decimal place we can imagine here at the end of it. We want to move it so there's only one number in front of the decimal place. So let's change that to 3.6. You don't need to do 3.60, but you can if you want. And then we moved it over 2 places. So it's going to be 10 to the power of 2. And that will be done. For the next one, we have 0.00104. Again, we want it to be one non-zero number in front of the decimal place. So we're going to move it over to here. Let's rewrite that now as 1.04. And let's just count how many places we moved it over. So we moved it over 1, 2, 3. This time it's going to be 10 to the power of minus 3 because we moved that decimal to the right. 3.6 by 10 to the power of 2 means it's a big number. Something that's really tiny, smaller than 0, is going to have, or smaller than 1, is going to have a minus power, meaning that we've moved it over to form a decimal. So these would be your 2 answers for the final 2 questions. If you have any questions about any more of those, or you're not sure still where you went wrong, just talk to me, and I'll, of course, be delighted to help you out, guys. Okay.